This is the intro video for Algebra 1, Section 8.3, and in this section we're going to be looking at how to add and subtract radical expressions. And to help us understand how to work on this, we're going to remind ourselves how we add like terms. So over on the left, 3x plus 5x, this is a very old expression that we have been working on all year, really. So if we are adding two like terms, 3x plus 5x, and they are like terms because this x and this x are the same, the variables are the same, then what we do is we add the coefficients, so 3 plus 5 is 8, and we leave the variables exactly the same. So when we are adding radical expressions, it's really a similar idea. Notice how this over here looks real similar to what we have over there on the left. Instead of 3x plus 5x, it's 3 root 2 plus 5 root 2. So because of that, we would say that these two radicals are like radicals. Or excuse me, these two terms are they're like terms because they have like radicals. In other words, the root 2 and the root 2 are the same, and so they'll function almost like an x. If one of them was 3 root 2 and the other one was like 5 root 7, those would be unlike radicals, and so they would be unlike terms, therefore we couldn't add them. But because these two radicals are the same, we can add them. And the way that we add them is just like the way that we add like terms when it comes to algebraic expressions, like we did on the left. We're going to add the coefficients. 3 plus 5 is 8, and we leave the radicals the same. So I'm hoping you see the similarities here, how the root 2 really serves the same role as the x did in the other expression. We're going to try to use this idea to practice with a couple of these here in our video. So let's start off with number 1. Number 1 obviously is a radical expression. I've got two radicals within, one radical within each of the terms here. And notice that the radicals are the same, right? They're both square root of 7. And so that means that the two terms are like terms, and I can add them up. The way that I do this is I add the coefficients. 4 plus 6 is 10, and I leave the radicals the same. There's nothing more that can be done to simplify this, and so I know that I'm done. Let's move on to number 2. Okay, so in number 2, again, notice that we have radicals in here, and so when it comes to time to try to add or subtract these, we need to make sure our radicals are the same. So the first radical here is square root of 5, and the second radical is square root of 5x. That x is inside the radical. What this means is that these two terms are not like terms because the radicals are not the same. And so at this stage, we would just leave this alone. We would, if this were on a quiz or a test, we would probably just say, already simplified, something like that, and we'd move on. The reason why we can't add these is because they are not like terms. The reason they are not like terms is because the radicals are not the same. They need to be exactly the same. Okay, and then number 3. Again, we're supposed to simplify if possible. So I'm going to look through my radicals here. You can see that there's a lot of them. I'm going to see if any of them are like. So this first one, the radical is square root of 11. And the second one is square root of 11. So those are like radicals. But this one right here, root 21, it is not like the other two radicals. It can't be simplified any further. Next time we'll look at some of these where maybe some simplification would change things a little bit. This is not one of those cases. So I can add the first two. I can add these two together, I guess technically subtract them. But the last one I'm not going to be able to do anything with. So when you are adding like terms that have these like radicals, what you do is you combine your coefficients. This time it's going to be subtraction. So 3x minus 6x is negative 3x, and then root 11, so negative 3x root 11, plus x root 21. And again, because those two terms there are unlike terms, because the radicals are different, it means we cannot combine them or simplify this any further, and that would be our final simplification for this one. All right, so when I see you in class next time, we'll be practicing with these types of expressions again. See you then.